Hey guys, so today's experiment is going to be changing states of matter. We're going to change we're going to change the solid to a liquid, and we're going to be working with chocolate. Okay, so the chocolate bar I'm using is Hershey's bar, and I'm just cutting a small piece out of it. And again, we are doing an experiment, therefore that means we have to test three different things. So in this case, we're going to test out which is our question, which place or area where we're gonna heat the chocolate up will be the one that melts the chocolate the fastest. All right, how does that sound? So we're gonna try to melt the chocolate bar or piece the fastest, and we're gonna see which one does it the best. Okay, so what are the three contenders? So here we have a heat lamp. Okay, I will tell you the temperatures in a bit. We have a heat lamp. We're gonna go ahead and move over here. And we have some hot water. I don't know if you noticed, but there is steam coming out. So it is very hot. And then we finally have our hot plate, which is on about number 4. So it's around in the middle. I didn't want it to be too powerful or too strong of a heat. I want it to be balanced, okay? Where it's in the middle, not too hot, okay? So that way it can be a challenge for everything else. So I want you to start thinking, which one of those will melt the chocolate piece the fastest? Again, we're going to use the same size for all three of them, okay? So the same size. And then the temperature is going to be the only one that's different. And we'll talk about the temperature once I set them in. So I'm going to set them down, okay? And I'm going to put them in there. And we're going to see which one actually melts the fastest. Okay, so we put them in there the same time, at the same time. Hopefully it was like 1 or 2 seconds apart, but everything else is just the same. So as we're doing that, I want to talk about how does heat affect the state of matter. Okay, so I want you to start thinking about labs that we've done before. So when we change the solid to a liquid, what did we do? We had to add heat. In this case, we're adding a lot of heat. Okay, we're doing that, and then whenever you want to change from a liquid to a gas, and that's where I had my coffee pot, my instant coffee pot, where it boiled the water extremely fast. Remember, it had to reach to a high temperature. I think we said 100 degrees to boil the water, and then it will turn into steam or water vapor. Okay, once we had the water vapor, it was so much steam coming out. Okay, we wanted to control that and cover and bring that water back. Okay, now we can't really catch all of it because we're in a big room where there's a lot of space, but we could try to catch it by set a cold container with ice, and the water or the water molecules started to collect into the cold air. Okay, same thing that happens in the water cycle. When you go and look outside, why is it so cloudy? The atmosphere is extremely cold, so the temperature drops fast once it's up there. So when the steam goes up, okay, it starts to condensate. Okay, all the water molecules start sticking one molecule with the other. So one molecule sticks with the other one with the other, the other one with the other. So they start sticking together until eventually, when they stick together, they get heavy and it starts to turn into a liquid and rain. Okay. Once you have water, you take away the heat even more. You can either put it in the freezer, you can do the rock salt, the one we did, and turn it into ice within about 5 minutes. You can even do even something colder. I've done, I don't know if you've seen it in my previous video, I've done dry ice, which is frozen carbon dioxide, and it's extremely cold. It's negative, I don't know, it's really cold. So whenever we put the water in there, it freezes, and when it freezes, it turns into ice almost instantly. So very, very fast freezing. Okay, so all you have to do is remove the heat and freeze. All right, so let's look at our chocolate so far. Let me see if I can zoom in a little bit. Okay. All right, so right now there is no much of a change. I can see some of it melting. I'm gonna go ahead and move it a little bit. Look at that. Did y'all see it? It started to expand because whenever something is hot, it expands like a balloon would expand if it's hot. Eventually, it will pop. In this case, the molecules are expanding, therefore it is melting. Okay, that's the heat lamp. Okay, let's look at the water. Okay, and in the hot water, same thing. I'm gonna shake it a little bit. Okay, as you can see, some of it is running off. Same thing, it is expanding, it is melting, but it's a little bit harder to tell because it is underwater, but it did get a little bit bigger. Okay, the size of it kind of increased, kind of like a hot air balloon. Whenever you add hot air, it starts to increase and get bigger, and it expands the air and it pushes it up. Okay, here it's trying to expand the air, expand the chocolate because it is trying to melt. Okay, and over here, looks like our chocolate is burning. Okay, so I can smell chocolate. Some of it has toasted from the bottom, so it has burnt. So it has gone way past down. It definitely passed the what's it called? The melting phase where it starts to burn. Okay, so far the one that has melted the best is the heat lamp. Okay, and what I'm gonna do is we're gonna take temperatures. I have my temperature reader, okay? And then let's see what temperature does it have. Okay, that one reads 67, maybe 75, and it keeps going up and down. So it's about 75, 65, between 67 and 75. So it's pretty hot. 67 to 75 degrees Celsius. If I was to convert that into Fahrenheit, that's about 166. Imagine going outside and being 166 degrees Fahrenheit. That's pretty hot. Okay. We're actually sticking to Celsius because that's what scientists do, and it is about 68 this time. Okay. So I'm gonna go into the water. Again, the water will start to lose heat. Okay, because it is of course water loses heat. Little at a time because nothing else is continuing to heat it up. So the temperature is at 44, but when I first started and I checked it, it was about 80 degrees. Okay, it was really steamy. Now the temperature has gone down, and when we come back, I bet the temperature has to go down even more. So it's gonna start cooling down a little bit. So it kind of got into the maximum amount of heat, I guess we can say. Okay, and over here, my chocolate, it's at a whopping 130 degrees Celsius. So it is extremely hot, and it is definitely melting. Okay, so I'm gonna grab a stick, and I'm gonna go ahead and start pressing on it to see how much did it melt. Okay, so it didn't really melt that much, as more as it kind of burnt it. Okay, so that's the end of my experiment for here. It's starting to smell like burnt. Okay, so I'm gonna leave it to the side because I don't want it to really burn a lot. Okay, over here we have the water, and same thing. Sorry if my hand's a little bit shaky, but oh, this one really did melt it pretty well. Okay, I don't know if you can see, but look at that. Okay, it melted it pretty well to where it's very soft, kind of like it started to look like chocolate syrup. Okay, so if you ever tasted chocolate syrup from Hershey's, it kind of looks like that. Okay, all right, and then finally let's look at our heat lamp, and let's go ahead and mess with it a little bit. Ooh, look at that. So definitely melted it the best. I'm gonna say that the heat lamp was basically one of the best ones that melts it. Even though it wasn't too hot, remember the hot plate was extremely hot, so it started to burn it. Okay, that's something we don't want with chocolate. Chocolate, we just want to have enough temperature to melt it. Okay, so it did turn it from a solid to a liquid by adding heat. Okay. how can I turn that chocolate back into a solid? Let's start thinking about that. You have that chocolate melted and you want to turn it into a solid. What do you need to do? Okay, yes, you have to take away the heat. So I have to remove it from the hot plate. Okay, turn off the hot plate and then let it cool down. That's removing the heat. So I'm taking away the heat. So instead of being about 80 or 70 degrees Celsius, it's now dropping the temperature to the temperature of the room. And in which case the temperature of the room is not as hot as, so let's see the temperature of the room. It's about 21 degrees Celsius. So it's not even close to 70. Okay, so eventually that temperature difference is gonna make it cool down. When it cools down, it becomes a solid again. Just like we created a solid in water, we turned the water and we removed the heat and it turned into a solid. Same thing for the chocolate. The chocolate is going to start to turn into a solid once you remove the heat. Okay. All right. So if you guessed the heat lamp, you are correct. Okay. Remember, heat lamp. What can we compare that? What can that model compare to in the real world? Hint, hint. Yes. If you look outside, there's a big shining heat lamp. What we call that heat lamp, the sun. The sun constantly shines light and heat at us. Okay, when it does that, it adds heat. That's why we have the water cycle. That's why water turns into water vapor, or that's why ice melts. So notice that it's snowing in other places right now. Eventually, the sun is going to hit that ice and it's going to melt it. Okay, it's going to turn it back into a liquid. So the sun is very important because it gives us heat. Of course, light, but right now we're focusing on heat. Okay. Thank you so much, guys. I know I talk fast, but hey, hopefully you understand it. Hopefully you get a little bit of the main idea, which is the more heat you add, the quicker it melts, or the more it melts, or the faster it melts. If you take away heat, it goes the opposite way. You are going to eventually condense it or freeze it, okay? Depending on how much heat you take away, okay? All right, so start thinking about those different things that can turn into liquids. For example, glass. Who knew glass can turn into a liquid? All you have to do is add heat. What about a rock? Yes, a rock can turn into a liquid. What? Yes, have you ever seen a volcano? The lava that comes out is actually melted rock or molten rock, okay? It's actually a rock that has been melted and turned into liquid. And then eventually when it comes out here, the temperature is much cooler, so it cools down and it turns back into a solid. You see how cool this is? It's all connected, guys. So please try to keep an eye out for different solids and liquids and gases that whether you add heat or you take away heat, is it going to change in state of matter? All right, guys, when you see fog outside next time, think about me. When you see the rain, think about how did that happen, okay? And think about the lab that we just did, okay? See you guys next time. Have fun.